So here's a quick introduction into how to simplify algebraic fractions. So at the top we've got 15x divided by 5, and just like with a regular fraction, I know that 15 divided by 5 is 3, so I would cancel those two out and replace that with 3. So if I'm going to talk through that fully, what goes into 15 and 5? Well, that's 5. How many 5s go into 15 is 3. How many 5s go into 5 is 1. So I've got 3x over 1. 3x over 1 is going to simplify down to just 3x. Again here, what goes into 4 and 16, because there's a common factor there, that's 4. How many 4s go into that is 1. How many 4s go into 16 is 4. So I'd write that as 1 lot of x over 4, so just x over 4. Pull out the common factors here. Well, 5 goes into both of these. So how many 5s go into that is 1, how many 5s go into that is 2. And then there's also a common factor in the second part here. The common factor is the x. So there's an x in both of them, so I can remove one x from both of those. X squared divided by x would leave me with just that solitary x. So I've now got 1 lot of x on the top, and on the bottom I've just got 2. Okay, so first of all, the common factor in this fraction at the top here is this x plus 2. Both of them contain an x plus 2. So that divided by that must just have a value of 1. So I could also technically put a 1 there if I wanted to. So all I've done is found that that divided by that must give me 1. So the whole thing must just have a value of 3 lots of 1, which is 3. So have a look at the one at the bottom. There's a common factor in here straight away, which is the number 5. So how many 5s go into that is 5. How many 5s go into that is 1. So on the top I've got 5x, and on the bottom I've got 1 lot of x plus 3. And there's no common factor in there, because this bit at the bottom, there's no 5 that goes into it, there's not an x in all of it. So that's as far as it works. So this bit here, the common factor is maybe obvious, may not be obvious, but what we can do is take a common factor outside, just to show we know exactly what we're doing. On the top, the common factor is 3, so I'm just going to factorise that. So I've got 3 lots of, and that would have to be x plus 3. And I'm going to divide that by 3. So now it's easy to see that the common factor has been taken outside, so I know that that divided by that will leave me with just 1. So all I've got at the end is just x plus 3. I'm not going to bother keep writing that little 1 there. Do the same thing here, so we'll factorise the top, and we're also going to have to factorise the bottom here to get the common factors. So 4 and 6, 2 goes into those, so that must be 2 lots of 2 minus 3x. And on the bottom, 2 goes into both of those as well, so it will have to be 2 lots of 5x plus 1. The common factor here is clearly these 2's. There's no common factors in these bits. So the 2's the bit that we're going to cancel out, so cross those 2 bits out. That will leave me with just 1. So I've got 1 lot of the bit on the top, 2 minus 3x, over the bit on the bottom, which is 5x plus 1. Okay, a few more. Take out the common factor, and we need to take out as much as we possibly can. So while 2 goes into the top bit of this, 4 is the biggest number, and that's the one we're going to take here. So 4 lots of x plus 2. And on the bottom, 6 is the biggest number that goes into both of those. So that'd be 6 lots of x plus 2. Now there's a couple of sets of common factors here. 4 and 6, I know will cancel, because 2 goes into both of those. And likewise, x plus 2 divided by x plus 2 is just going to be replaced by 1. So I've got 2 lots of 1 on the top, which is just 2, and on the bottom I've still got that 3. So all of that simplifies to 2/3. This one here, I can't factorise the top, it's just a single expression. So I'm going to factorise the bottom part. And the common factor that I can take here, the biggest one is 4. So that'd be 4 lots of x minus 3. So the common factor here is just between the 8 and the 4. There's no x in everything else. So simplify that bit. What goes into 8 and 4 is 4. So that'll be 2, and that'll be 1. So on the top I'm left with 2x, and on the bottom I'm left with 1 lot of x minus 3. Okay, this is a slightly trickier situation we've got at the top here. And what you should be able to spot is that this expression here, x minus 1, this is the reverse of that. So it's effectively been multiplied by minus 1. So what we've got in effect here is we've got something, a little bit of algebra on the top, and then we've got the reverse of that on the bottom, that multiplied by minus 1 on the bottom. So this must have a value of minus 1. So that's always true where the statement on the bottom or the top is just the reverse of the other statement that's there. So let's try and put that to some kind of use with the skills that we're building. So on the top here I need to factorise this, because that's pretty much what I'm going to be doing every time. I've got 5 lots of x minus 2, and on the bottom I've got 2 minus x. Now, it's maybe not overly obvious what will cancel, but this x minus 2 is the reverse statement of this 2 minus x. So I know that that and that will cancel, but instead of being replaced by 1 like I'm used to, they're going to be replaced by a minus 1. So now I've got 5 lots of minus 1, so this must have a value of minus 5.